So my name is Drew. I'm an educator here with Grok Academy. I'm New South Wales based, but I am a big rural and remote teacher. So I've spent a lot of time teaching out in regional and remote New South Wales. And I want to start off with just sort of going over what we're going to talk about today. So we're going to look at the foundational concepts of programming, in particular, the famous Hello World line. We're going to look at why coding can be so difficult to master. We're going to talk about cognitive load, which is something that often we think about, but tangentially to when we're programming. And I'm going to give you some strategies for teaching code that addresses some of those difficulties that students find. So here are three classic statements. One's in C, one's in C++, one's in Java, and one is in Python. What do they all have in common? The answer is that this is where most students begin. No matter the language, the first activity, and even when I was programming and teaching programming, I would do the same thing. I would start off with a hello world. And I go, look, you type this in, you print it out on the screen, it says hello world, yay. Normally now let's change it to make it say your name instead of world. It's also one of the hardest things that we can do for a student, because I'm going to make things a little bit easier on myself, and I'm going to pick the easiest line to print that we can sort of put into the program there, and I'm going to pick Python, right? If we simplify that down, and I'll show you an expanded version of this in a moment, there's a whole heap of things that we require students to know in order to print this hello world statement. They need to know names, so they need to know built-in names. They need to know what delimiters are, that we use parentheses, that we use quotation marks. They need to know that this is a function call and that the print statement is actually going to output something, right? And I was always absolutely ignore that. I would 100% just go type this and see what it says and do it. Because if we take this sort of even a little bit further and expand this graph out, there's even more things that we consider. We need to talk about the quotes. We need to talk about different types of quotes. So if we're looking at Python specifically, what do single quotes mean to double quotes to triple quotes? What happens if I'm using a contraction? So I use can't in there. We need to look at whether it puts on a new line character, whether it does that by itself, what these different function calls mean. Why we have to use the word print, because print seems a bit illogical these days, right? There's a whole heap of background concepts that we require students to know. And you can see here, we try and simplify that down. We show here that between the quotation marks, that's green to show that that's the string. We show that the parentheses are the same color, so that if you were to have nested parentheses, they would be in different colors. We show that the function call is purple. We do that to try and reduce the load. But when you're a beginner programmer, you don't know that. You just have to take it at face value. You just have to take it that the program, whether that's VS Code, whether that's Grok, whether that's any other kind of IDE, is going to do that for you, and that it does it consistently. Because often the approach that they take and the colors that they take aren't uniform. So what we might use in one example, say in VS Code, when they come onto Grok, it's a different color, and that throws students. And we breeze past it all. We just go, nope, don't worry about any of that right now. Just do print hello world. Why? It's to reduce cognitive load, right? So cognitive load it's a theory based on how learners acquire knowledge, but also what they need to do in order to get that knowledge, what they need to bring, how much they actually need to think through when they are programming, when they are reading, when they are writing, when they are learning how to kick a football. Our brains are processing all this new information to take it from that short-term to long-term memory. But to acquire those skills, whether that's programming or outside of programming, we have to think about it. Nothing comes fluidly and naturally to us. Even kicking a football requires us to have so much foundational knowledge on hand skills, eye coordination. Can we walk? Can we lift a leg and balance while we kick a football? The same applies to programming, and we don't think about that. So we never talk about all that. We never introduce that straight away because we don't want students to become burdened with the idea of, hold on, before I even type something, I need to think about all this. We go, no, type it, see the response, and then I might explain to you a couple of these things. So that's one way that we try and manage cognitive load, but it's also not the only way. Because I know that when I've run different intro to programming lessons when I was teaching, it's this idea of misconceptions. I will let a student come in and I'll say print, and sometimes they might go, oh, well, this is a sentence, right? Print, open parentheses, quotation marks, hello world. It's a sentence. Sentences start with a capital letter. Perfect. Capital P, big P, R-I-N-T, hello world. And what happens when they do that? They get this big red error message that's normally involving something they can't understand, where they say print hasn't been imported because the Python doesn't know what to do with something like that. These days it gets a bit easier. They often say, did you mean print? But not always. Or another misconception that someone might come in is if they've come from something like Java, where it gets drilled into you from Java that statements have to end with a semicolon. And I know that, the moment I would always have a mistake when I was programming in Java, 99 times out of 100, and I'm not ashamed to admit it, would be a missing semicolon somewhere. So they go, not to worry, I've come from Java, semicolon on the end. We get an error. So what we do is we introduce the print hello world statement, or the equivalent in another language, and we just give it to them so that they can form their own conceptions. They can reduce their own cognitive load by bringing their background knowledge from the classroom in the hopes that they'll be able to puzzle it out. That they'll be able to puzzle out that if it doesn't work, they'll be able to use a semicolon or a quotation mark. That they'll be able to use their mathematical ability that they bring into the classroom to know that when you open a parenthesis, you close a parenthesis. These are really, really important, but they can get us into a lot of trouble. If we don't tell a student why we use print and that we can start to substitute print with different things like input, like str, if we're, again, focusing on Python, that's a function call, they don't understand why. They don't understand that this is something that Python can do. That's a little thing that's built into it. And there's lots of different things that come built into, lots of different functions that come built in already, right? So we've got to let them go up to a stage and then pull them back in and say, okay, well, we use quotation marks because we now need the compiler to know that it's a string. Okay, what's a string? A string is a series of characters and numbers and spaces and your catch-all. And they go, oh, okay, I get that, because when we did Hello World, it was letters and spaces and normally an exclamation mark on the end. So we let them build up their conception. We let them build up their knowledge and introduce misconceptions and misunderstandings in the hopes that we'll catch them later and then they'll be able to continue on. And the problem that we fall into is when we're introducing programming concepts is not always are we as teachers great at capturing those misconceptions. And too often we go, okay, well, let's move on without a student having that fully constructed model of, okay, what did I just type and why does that mean anything? Why do those parentheses even need to be there? So I love this quote here from Charles Babbage, the grandfather of computing. I've been asked on 2 occasions, I've been asked by members of parliament, pray Mr. Babbage, if you put into the machine the wrong figures, will the right answers come out? I'm not able to rightly apprehend the kind of confusion of ideas that could provoke such a question. Again, these are parliamentarians, albeit, in very early stages of computing, who never had those misconceptions checked. And to a degree, a lot of this happens now, especially as we're getting further and further into the abstracting away a lot of, what makes computers tick, that students don't have to have a really foundational knowledge of computing in order to do programming. They don't need to know how a computer stores different commands in order to execute those commands. Thankfully, we've moved on from assembly language, which, is way too hard to use, into languages like Python. But the same thing applies. We assume that what we type just gets fed in and spat back out to us, and we need to address those misconceptions. Because coding is hard, and we often take for granted that, you just pick coding up. By getting in there in year 5, in year 6, in year 7, you'll pick up coding because you have English. But we started learning our letters and numbers when we were 1 year old, and we'd be pointed in front of a book that had A for apple, B for ball, C for cat. We've built that up. We've addressed misconceptions over years. Everything is hard in the beginning. What we need to do is we need to recognize that learning to program is hard, and we need to start to take steps in order to reduce that initial barrier. Once we can get over that initial barrier, we can start to progress forward. We're quick to say that everyone can code, but can they really? We're quick to say that everyone can kick a football, but do we say that everyone is a footballer? We're quick to say that everyone can write, but not everyone will be a professional author, right? We have all these other subjects where it is okay to be average. It's okay to learn how to string a sentence together. And going back to the English example, to not use a capital letter to start a sentence, and not use a full stop, and not use correct punctuation, and not use correct spelling. Is it 100% correct? It's not. If I, as a student in a year 7 class picking up English for the first time, was to submit that into a teacher, would they understand it? The answer is yes. Unfortunately, when we hit programming, though, the requirements or the consequences of error are so important, because a computer cannot understand that becomes a huge barrier. And they go, no, I'm not a programmer because I can't get things right the first time. Whereas in 99% of cases, I don't get things right the first time. I often hit errors. I often have the big red syntax screen saying there's been a value error somewhere that I need to correct. I would still call myself a programmer. But because students hit an error in those very early stages, they don't know what to do. So we need to reduce that burden, still learning, while keeping things challenging. Because if we were to just stick to Hello World, for example, and go, now I want you to do your timetable for the day. Period 1, English. Period 2, digital technologies. Period 3, in just string. Students are going to lose interest. We need to build upon that. We don't just stick to students forever writing the same words again and again and again. Basic words without sentences. We build that up. We need to build the same up in programming. So now that hopefully you have an idea of why we need to reduce that load, why we need to reduce that challenge, that initial challenge, while still building in activities, I want to talk about some different ways that we can reduce that cognitive load in our practice. And there is a resource here. The Raspberry Pi Foundation has released these really, really awesome pedagogy quick reads, which when I was in the classroom was such a good thing, because they're double A4 pages and they're designed to just be like a pamphlet almost, but they go into so many different topics. But the first one I want to talk about is the cheat sheet, because a cheat sheet is such a dirty word, right? Why? I can't have a cheat sheet. No, I can't give them a cheat sheet. That's not right. I'm giving them the answers. Despite the name, a cheat sheet is not cheating. My 5-year-old daughter is learning how, she's just finished kindergarten or her first year of formal schooling. And I walked into her classroom, and on the wall, I saw, the typical kindergarten or the typical early learning classroom, A, apple, B, ball in uppercase and lowercase on the wall with pictures with letters, right? And was I happy that was there? Was I happy that the teacher had put that up on the board? 100% I was, because my daughter's learning to read. My daughter's learning to read and write. I wanted to learn how to form a letter. People often go, and you'd be hard pressed to find anyone who'd walk into a year 1 classroom and tear the poster down off the wall, right? That's a cheat sheet. The hope is that as my daughter proceeds, she'll go, okay, A, all right, I'll look up there. B, I'll look up there. C, okay, no, I've got A this time. I'm good with that. B, C, the hope is that they build familiarity. And to be honest with you, if we were to look here where we say print multiple values of different types, right, and using formatting of different outputs or formatting of strings, if a student could look at this sentence, take the main part of it, and then apply it into the concept of which I've asked them to do, which could be today is Thursday, tomorrow is Friday. Is that bad? I would argue the answer is no. It is more dependent on what you're trying to teach them. If you're trying to teach them print hello world, well, maybe you don't want to give them the answer in an assessment task. A cheat sheet isn't the be-all and end-all you need to give them every time. But if a student needs to look in when they're working with text to know what happens when you do a single quote, a double quote, or 3 quotes, I don't view that as being a bad thing so long as they're still completing the task that I'm asking them to do. And that might be to iterate through a list in Python of different values, right? If they need to know how to print out that list, but they've got everything right up until then, perfect. They then don't have to go, oh my goodness, I've got this blank slate and I don't know where to start. The other one that I want to talk about is pair programming. And pair programming is a really good one for classrooms because often we struggle with devices. There's not a lot of schools who get up there and say, oh, I have 1-to-1 devices. So we go, cool. Myself as the competent as the more competent programmer, I'm going to work here. And normally what you would do is you might pair a competent and a less competent programmer. And you go, I want you two to work together. And most of the time that devolves into the competent person doing all the work and the less competent person sitting down and just going, oh, this is great, you're going to do it all for me. And the teacher goes, well, look, they're working with someone and that's fine. Pair programming is actually slightly more involved than that. And it involves a driver and a navigator. The driver is the person who actually uses the computer, who uses the mouse and keyboard. They're responsible for putting everything into the programming. Whereas a navigator might be the person who's sitting in the back seat going, okay, let's actually think about this. If I want to have the computer ask for my name and then print out hello, Drew, well, what do we need to do? We need to ask for the name, we need to store the name, we need to print the name. How are you going with that, driver? And the driver will go, oh, that's fine. In input parentheses, what is your name, ? Right? Awesome. The idea is that both of these roles have that cognitive load that one person isn't responsible for typing, because students take ownership of anything that they type into a computer. If it's wrong, they got it wrong. They're typing because they're the interface to the computer is the reason it got wrong. And students go, the moment they get something wrong, they go, nope, programming's not for me, not a programmer. The idea is that splitting that helps reduce that load. But also if myself as the driver gets in there and I do a capital P for print in my hello world statement, that the navigator goes, oh no, hold on. I think that might be wrong. We're working together. The thing that we need to do with that though, is we need to switch sides. One person cannot be only the driver and one person cannot be only the navigator. We need both students to do both roles so that they get an idea of both portions of it. And that might not be equitable. It doesn't need to be equitable. You might have a more competent person being the navigator and telling the driver what to do most of the time, but you'll switch it up every once in a while. You need to know your context and your students to know how to apply that better. The other one is a worked example. And even in university courses, when I did my degree, they'd often give me the skeleton code. When we're working with Java, the basic code, so that you're not sitting there in a blank page going, I don't even know where to start. Right? In this example here, which is just a simple Python turtle program, the idea is that I don't need students to know what from turtle import everything means. Right? I'm going to have a little explainer here so that that's not foreign to you, so that you can understand what it means. I'm actually, in my lesson, focusing on the range, focusing on students understanding how loops work when we're repeating through different things. And you can see here that in my example, how many times does this loop run? Okay, well, a student needs to look at this picture and go, how many different times does it actually make this for thing? Well, I've forgotten how many sides a square has in it. I'm going to put 5. And I get a wonky looking shape. No, okay, it's not 5. But I know where I've gone wrong. Maybe that's too many. Okay, I'll reduce it down to 4. The same thing with what value goes here. If I'm targeting a specific thing, and I've gone, well, my students, when they did all that typing of Hello World, when they did all that initial programming, didn't understand the role of parentheses, the different functions. Here's where I need to target. I'm going to give them 90% of what they need to do. They're going to do the last 10%. They're going to have a win. They're going to demonstrate to me that they understand the thing that I need them to do. And hopefully, they're going to understand how all these different parts of a program work together to form the whole. And again, there's another Raspberry Pi Foundation quick read on those. The other one is something that is used a lot in junior schools, in primary schools, but less so in high schools unless you can't get access to a computer because NAPLAN's taken them all for the next 3 weeks, right? And it's the unplugged lesson. Computers are so abstract for students. Like I spoke about before, they're a black box of things go in, things come out, and I don't understand how the rest happens. By using different tools, like some of the ones in CS Unplugged, and those CS Unplugged courses are great, but by using a lot of different tools in context that students know, it removes that initial cognitive load of going, hold on, now I'm learning a computer and the keyboard and mouse when I've only ever been exposed to an iPad, and the Grok interface or the VS Code interface, and this, and the concept that I'm actually trying to teach students. By saying, we're going to do the simple, I'm going to give you a bit of chalk on a concrete slab, and I just want you to do a simple, going back to this example here, forward 3 steps, drawing the pen or drawing the chalk behind you, right 90. Forward 3 steps, turn right. Forward 3 steps, turn right. The idea is that they'll go, oh, I understand that. I understand how to draw a square, sir. Don't look at me like that. I go, spectacular. Nothing that you just did here is harder than anything we have to do in programming. We're just going to use a few extra words to do it. And I can introduce that with less words by saying, instead of for I in range, I'm actually just going to say less than 3, or, while every time you do it, put your hand up. And when you put your hands up 3 times, you're done. I'm going to introduce it in a context that makes sense for my students, but that doesn't introduce the terminology yet because they don't need it yet. When they're outside drawing squares on the basketball court, they don't need to know for I in range. I might introduce that later, or I might say for, but I don't need to do it all. And I need to know where my students are in that. Because just to summarize a lot of this, the way that we teach programming needs to be more than just type this and do this. because students will eventually fall into trouble there. They'll eventually go, no, I can't, or I don't understand, or when you ask them to apply something to a new context, like drawing say going back to our square here, by drawing a pentagon. If I don't understand what right 90 means, that right 90 means that internal angle there, when I ask you then to go and draw a pentagon and to figure out the internal angle of a pentagon, I'm not going to know, right? There's so much that goes on, even going back to that print hello world statement, that we can just give to students sometimes, but eventually we're going to have to catch them back up. And the way that we introduce these is important, because we need to reduce that cognitive load on a student. Otherwise, they're just going to check out. And I've had it so many times that they just go, I'm not typing 16 lines of code. And I go, okay, I get it, but we need to push through. Oh, but if you were to sit them in English and say, and I'll use an example of my daughters here, but if of course that doesn't work. But if she's to give me 5 lines of poorly written, poorly grammared writing, I go, spectacular. The same needs to apply to programming. We need to treat programming as what it is, which is learning a language from scratch. But instead of starting it reading very, very simple children's books, we're starting them in the confines of the curriculum, in the limited time frame that we have, for an hour a day, at most a few days a week, right? So the burden that we place on students needs to change for our students so that they can achieve success. And there's so many different ways we can do it. There's even other ways that we haven't mentioned here that go into pedagogically the way that we can introduce new concepts like PRIM, which is, again, another thing by the Raspberry Pi Foundation, which you're nodding your head. I'm glad to see you've heard of it, because it's such a good way to present things. Because that's how we get our students involved. We overcome these initial barriers so that by the end of it, they're going, oh, not only do I understand what I do, not only can I demonstrate that skill that you've shown me with Print Hello World, but I can also demonstrate why I'm doing it later on so that I can do it again. And I wasn't just introduced with the slab of, you have an hour and I need you to write out this program, get going. And the moment I open a parentheses and don't close it, I'm done. Because that's why we start with Print Hello World, is because we go, it's engaging in that it shows you what input corresponds to output, and that processing happens, but it's not writing out, the entire curriculum in a message that requires you to do all these different things. It's very quick and very simple, but too often we go, that's enough, and I actually don't need to focus on everything else. That's what I had presented for you, but I wanted to know if there's anything that you have had that you might have encountered in your classroom, or that is there anything that you've, particularly when you've introduced coding into your students, have gone, I always get lost with this, or I never know where to start, or anything like
that? I think for me, especially at the school I'm at now, like I've just changed schools to another one just recently, and I do it I've got all the grade 7s in the school and all the grade 8s, and my biggest thing I find is literacy. Sometimes computer usage. Some people can't save a file, can't use a file, can't do all kinds of different things, and they just feel like overwhelmed to start with. But I find literacy, we have quite low literacy here, and it's just reading. And me pulling it on the screen, me doing bits and pieces, me doing it together. I've used CS Unplugged things, but I find that's something that comes up quite a bit. It's like they just find it's a lot of reading, and then like the error screen thing there, the red screen failure. They feel like they failed before they even start, because you can't partially get it right, and that's a hard thing. That was actually why I chose this PL specifically, because it's I don't know, something I quite struggle with at this school. And we have unstreamed classes of it. So we have some really bright kids who come in with years worth of programming, who are well advanced, and people who come in who basically can't read at all and have no interest in doing so, like doing programming, doing IT in general. Yeah, that's kind of, and I try to do things on. I use Playground quite a bit. They used to use, they used to install an environment previously at the school, but then it just got too hard with the school computers. So now using Grok Playground is awesome for that because I can just jump on there and do a bit of stuff, and I'll do it on the screen. We do it together. We break apart. They might do something. I don't know. Kind of a question with that is something I use as well with them is kind of going back and forward, doing different things. But the thing I kind of leave them to do over time is Python for beginners. Is that kind of where, like, is there anything easier that's Python literacy based on Grok that you can think of?
But literacy based specifically,
That's probably where we start.
To do that would be where you would start. The other thing is also if you want to check those foundational concepts while removing the literacy component, there is nothing wrong with doing block-based coding.
Yeah.
And I know that, and some people, I can hear them in the background going, no, we can't do that. But there's nothing wrong with checking concepts in block-based coding and then extending that later, right?
Yep.
And you can do some of that in Grok with the one that I've used most recently was our Smart Garden courses with our DTF challenges.
Oh, yes.
It's the same course that's applied in Blockly and in Python. So depending on what you need to do, they can, that you can have students who have less of a literacy focus doing the block-based, but they're still working towards the same goal. And there's a few of those. Even that's where you get to something like MakeCode, right?
Yep.
And that has the toggle up the top where you can flip between Python and JavaScript and I think they just call it blocks.
I think it's just called blocks, yeah.
Yeah, right? Where there's nothing wrong with you in pulling pulling one of the blocks in and then flicking over to the Python side and filling in that block.
Yeah.
Right? And I know the challenge there then becomes, well, how do you know you just didn't do the whole thing in block code and then the button? And that's where we need to use that idea of formative and summative activities.
Yeah.
Go, I actually don't mind if you do this whole thing in block coding, but know that I'm going to check on this later. And even introducing things. We're doing for loops. I'm going to check at the end that your for loop works the way it does. So if you want to use blocks now, go for it.
Yeah.
But know that when this assessment comes around and I need you to do it in text coding, and I'm going to not do it on MakeCode, say, where you get the toggle at the top.
Yeah, this is where we get to.
Know that this is where I'm going to focus on.
Yeah.
And they go, cool. And that works in kind of the way of a cheat sheet as well. And again, for low literacy, there's nothing wrong with a digital cheat sheet where they can copy and paste it in.
Yep.
There's nothing wrong with you giving them the concepts, because the idea that low literacy is a deterrent is so real and so relevant.
Yep.
But for me, with what I'm teaching with programming, I don't need to know every single little piece of literacy. I don't, if we're talking about then saying I need this consistent output, this consistent print statement, there's nothing wrong with me giving you the string and having you giving it to the class.
Yep.
Right. And again, you've got to know your own context of that. But giving a student or the list of strings that they're going to use, where they don't even have to worry about that. And then it just focuses on syntax. Can they use that string, put it in quotes, or, not if you want to give them that as well, put it in parentheses, put a print statement next to it.
Yep.
So we're too quick to say you have to do everything, type everything from scratch, when that's not often the case. And that I know when I'm learning a new concept, I will 100% go to, Stack Overflow or these days ChatGPT, and have less so ChatGPT, but more so Stack Overflow. Grab that slab, paste it into my own code, and go, okay, where's it broken now? I'm going to fix it, and I'm going to demonstrate that I can do all that stuff while I've done that. So,
we may get cut off because Siobhan, our events person, scheduled the event, so that was my 5 minutes. But one thing with low literacy is you could present the text to them and they have to find the error, or present the text and they have to change the color or change the angle or change the, they don't have to type it, because part of literacy is the typing of the text, right? Yep. So if you present them with the program and then they can modify the program or even backtrack and say, this is the program, let's look at how do we plan that? How could we write that in a flowchart? How could we write that? And give them, even backtrack to the cut and paste. Here's the blocks, put them in the right order. Because if they're reading at a primary level, cognitively, some of them may still be at a primary level. You can either cut and paste or you can do it yourself. Or get them to do it. Get them to do it in PowerPoint so that they can, manipulate. That will improve their digital literacy. There's lots of different pseudocode, writing the code as sentences. Those they're the sorts of things. Down pat. Because the priority is the logic, and if they're still using blocks, that's okay because legally we have to differentiate, right? So even if the curriculum says they must be doing text-based coding, if they're not text literate, we can do it with, and I've just put some links in the chat. Yeah, I've been seeing them, So the last two were Blockly Python and just Blockly programs. So the Blockly Python is a good starting point as well. It's a good transition from year 6 to year 7 where they've just done blocks and now they're moving into text. You could start with Blockly Python because that would be familiar. So for next year, perhaps.
Yeah, it could be a good play. No, it's hard with once a week, isn't it? Like I've got 1 hour a week. It's and they forget it. Like that's not a way to learn language.
They do.
Imagine an English teacher with that saying, "Oh no, I'm going to teach them English in 1 hour a week." They say, "No, that's impossible."
Forget it next week.
No. But you might even give them like a punctuation task. Here's the code. Here are the things. Where are we going to put the brackets? Where are we going to put and set tasks that teach the grammar.
I've done debugging, print out things and stuff like that. Like, what's wrong with this? What's right with this? And that kind of stuff.
Yeah. So, or you could even like give the correct version and give the wrong version. Right. Now go and find, because some of them will be eye for detail. So you could sort of have for the very low ones that here's the correct one, find all the mistakes, circle the mistakes, circle where the things are missing. And then for the good one, the ones that are clever, don't give them the before.
That's an easy differentiation.
Just give them the find all the errors and fill in the blanks. These are the things that are missing, and as they find the word, they could cross off the bracket. And like there's four right hand parentheses missing, and they could just cross them off as they use them. Type task.
Like the English, put the word in the right spot.
Like in English, because you're teaching a language basically, and they assume they've got to use their the computer, but you don't have to use a computer. So another program which I'll put in quickly, which isn't on our platform, which I love, I use this for enrichment with Year 5, 6, is Pencil Code. And it's actually it's called CoffeeScript, and it's a much easier platform that has blocks and text, and there's a little button on the right where you can flip between the blocks and the text. So they can code in the text and then look at the blocks. And you can, and it's Turtle, so use it to draw shapes or draw a picture. And there's actually, so the Create Art, Make Music, they're tutorials. Let's Play also has a little dictionary with cheat sheet, and a dictionary of all different things already, like a sun. Copy the code, bring it in. Can you construct a picture using code? And that might be a really good transition for Year 7 at the beginning of the Year 2.
At that starting point,
nice.
Nice.
So what we'll do, Sam, is I will process this video and I'll send it to you, and then hopefully someone will find it interesting next year.
That'll be good. My wife and me are co-teaching next year all our classes, so she'll be keen.
Oh, good. That's wonderful. It'll be fun.
We've got a baby, so it's we'll be back in 40 next year.
Good. Oh, good. So so I'll send you the recording, and hopefully somebody else will find some time to watch it. I might try and edit out the start and the end, and they'll just get the productive conversation. Awesome. Alrighty.
Nice.
Have you got any other questions?
The quick one actually is, I've got 9-10 next year at this school. I'm doing the 9-10 class. Intermediate level NCSS challenge. if I had someone, I'm just kind of pre-planning in my head because we're kind of having to change the course a lot last minute.
Yep.
If I had someone for a bit of time, there's some keen programmers. What would come like logically after that in the first term? Because the advanced one won't be running in the first term, I think. Is that right? What would logically come? Is there like a Python 3 or something like that? You know?
Where I would go from there is if you've done say some of those earlier Python courses.
Yep.
One of our newer courses is the Introduction to Cloud Computing DT Applied course. It got released mid-year, and it requires those knowledges. It requires some of those early Python courses as a prerequisite, and it has students start to write their own API calls and to start understanding how we get data and to incorporate JSON data, which is the backbone of most cloud computing applications. So that's kind of that idea of extension on that.
Yep.
Would be the next place that I would start. And there's a lot in there. So if you're looking for one of those, we've done the NCSS challenge, and let's move on, I would definitely recommend that Intro to Cloud Computing course as a way to go, well, we've kind of been learning Python in a vacuum of, just staying here, but just staying within the platform, within our environment. But that's not what Python's used for. It's used for so much more than that. Now let's get out there and show, exactly how this is used in development.
Yeah. No, that's awesome. Yeah. No, I try to mix it up, but I use a fair bit of Grok I find, but I use like microbits and all the different things like that.
Yep.
But I tend to find I come back to Grok quite a bit for different things. But no, it's good. Yeah, because I was curious. I was thinking, I was looking at the normal Python ones, and I thought I'm sure there's something good, but no, that's awesome. Cloud computing.
So we've also got because it's free now for all your students.
Yep.
So we've also got Cyber AU project, which has privacy and security.
Yep.
And so then what you can do is, which is now in a version 9, Australian Curriculum version 9. So I have heard some schools particularly using it with Year 7, but you could use it with all students where they start the year with that and do their privacy and security. How do you set passwords? Why do you keep yourself secure? And that sort of thing. So that's another thing that you could use. Yep. There's also things like monitoring and securing networks. There's monitoring cyber threats.
Yep.
So what I might do is I might try and find, we've got a slide, a sheet which has got a series, like a suggested pathway, not that you could follow for you. And so I'll try and find that and turn it into a PDF that I can send it to you.
Oh, awesome.
Is that the cyber one specifically?
Yeah, specifically that would be the cyber one. Yeah, but that includes.
I made up a version of it, which I will find right now and send to you. I'll drop it in the chat there. Which I did it up a little bit easier to read than some of the others. Which kind of it is more cyber focused, but it shows that that sort of evolution specifically for cyber of where you would progress from foundation to all the way up to 9 and 10. And that is that one there.
Okay.
Cool.
And we also have now free open public webinars that cover all the version 9 concepts.
Yep.
So are you a K to 12 school or a 7 to 12?
K to 10.
K to 10.
Yep.
So we actually have 3 streams. We've got F to 2, 3 to 6, and 7 to 10.
Yep.
And they're on the website as well under professional learning.
Yep.
And so that might be even something interesting for the broader staff. It's not specifically to coding,
Yep.
There's just so much. I think the problem is just getting your head in an order.
I had to remodel the version for version 9 for all of the year 7s and 8s, and we're doing the 9, 10 right now because I do all the grade 7s, all the grade 8s, and we'll do 9, 10 next year. And remodeling it, putting in more cyber security stuff this year. Getting more that way inclined than it was previously.
So we've got a lot of cyber resources now because of the new curriculum. But even for your primary teachers, the F to 6 course have lots of activities, not just algorithms. It goes across every strand. So everyone F to 10 would be catered for if you wanted to run them as
Yeah.
PL sessions or something, or
Yeah.
if people are wondering how do they teach it.
Especially some of the primary teachers who are not necessarily in that field. Like,
No,
we notice
that's
that quite a
right.
bit here. Yeah.
That's right. So like we've got one specifically on what is data representation and what is privacy in a primary school. What does that look like? So how do you teach it? So it actually is, they're actually really good resources.
Yeah.
So, and they've only just been released. Brand new, hot off the press.
Nice. That was awesome.
Have a great, restful holiday.
Yeah. Thank you. You too.
Alrighty. We'll speak to you
Bye.
later.